The other thing that we want to talk about, which will provide you context around how this vulnerability in DNN came to be, is the dangers of Unicode normalization. So if you take some sort of user input and you perform a number of security sensitive operations, and then you normalize that user input in any way, you might find out that you've unintentionally introduced some sort of order of operations bug into your code. Order of operations bugs are pretty tricky to identify, but they usually always lead to critical impact. And order of operations bugs are my favorite bug class. You would have noticed there's quite a few research posts we've done which focus on order of operations bugs. But this is exactly what happened in DNN. They sanitized the user input before making a file system call. But before making a file system call, they performed Unicode normalization. What you can see here is code from DNN or .NET Nuke, where they take some user input, the file that's being uploaded, they get the file name, and then they do a bunch of sanitization through regex.replace. They validate the file name for having illegal characters, and they even clean the file name if it does, but then finally they make a call to convert those Unicode characters. And this is really where the unintentional chaos occurs. The call to path.getFileName ensures that only the file name is extracted, not an absolute path. The call to regex.replace is to ensure that potentially dangerous characters are replaced with underscores. And for validate file name and clean file name, there are defense and depth strategy to prevent any invalid file names. But the thing that's really funny is that they spend all this time preventing invalid characters inside file names, but then they finally apply a call to utility.convert Unicode characters, which in some essence reverses all of this effort that they did in the previous 3 steps or 4 steps. Because what you can do is essentially provide some Unicode characters that when they get normalized, they defeat the purpose of the previous security boundaries that they put in place. This is why this is called an order of operations vulnerability, because if they did the convert Unicode characters first and then proceeded with all of their security boundaries, they would have been safe. The normalization function itself, essentially it just normalizes it back to ASCII. So regardless of whatever Unicode is present, it's going to try its best to find the best fitting character inside ASCII. And as a result, this means that we can provide Unicode characters inside our file path name, inside our file name, that don't get caught by any of the previous security boundaries. But once they get normalized back to ASCII and find the best fitting character, they create a security vulnerability. The way that we exploited this was we used the full width full stop, which is a character that looks like a dot, and the full width reverse solidus, which looks like a backslash. But when these are normalized through the Unicode normalization process, they get converted to an actual dot and an actual backslash. It's quite interesting because what we can essentially do is influence the path.combine sync that comes shortly after this, so that it would reach out to our external server and leak NTLS